Now let's try to demonstrate on creating a doubly linked list. So here in NetBeans IDE, we'll try to create a new project, and we will name our project with, okay, doubly linked list. Okay, and the main class is doubly linked list class. Okay, the main class is doubly linked list main. Okay, finish. Okay, so we'll try to close the other applications. So first we need to create a class node. Okay, so let's right click on this package, then new, then the Java class. We'll name this one as node, then finish. Okay, for our class node, we need the reference variables of course, the type is node itself. Then since we need the reference variables for the previous node, so we have node previous, the relevant info is item of type integer, and the next reference variable is of type node also, node next. Then we will have the default constructor, I mean the constructor with parameters. Okay, so for the constructor with parameters, we will have the parameters here for the previous, the item of type integer, and the next. Okay, that is of type node also. Okay, here we will try to initialize the value. Okay, set the value from the parameters to these variables here. Is that previous is equal to previous. Okay, this dot item is equal to item, and this dot next is equal to next. Save. Then since we have already the structure for our node, let's try to build our linked list. Okay, double click on the package, new, and the class of Java is doubly linked list. Okay, so this will include our operations here. Finish. So for our doubly linked list, we need to have the reference variables that always points to the first node in the list. So we'll call that as head. And of course, the reference variable that should always point to the last node in the list, we have the tail. Then the default constructor, okay. So for default constructor, head is equal to tail is equal to null. Okay. Since at the beginning, head and tail are pointing to nothing, so their values are null. Now the constructor with parameters, Okay, and the parameters here are for the head and tail. Okay, course head should always point to the first node. That head is equal to head, and this dot tail is equal to tail. Okay, so check the spelling. We have O small o. All right, so after the constructors, we will try to validate if the head, I mean, if the linked list is empty. So we have a void type of method here. I mean, since we are going to verify, we're going to check, we will be using the Boolean type of method and is empty. Um, how will we check if the list is empty? Okay, by verifying if the head and tail are null. Okay, head so the null and tail is null also. Okay, we are using the ternary operation here. True, otherwise false. Okay, now we will try to populate the linked list by adding an item into the head. For example, so public, let's try to make the void type of method like add to head. So for this add to head, we need a relevant info that will be adding to head. So this is the component of the node which stores the relevant info in item. Then here, you have to check if is empty, okay, meaning if the linked list is empty, then we can add a new node. So create a new node. So add a new node here named new node is equal to new node. Take note in our node class, we have three parameters here. Okay, initially in our new node, the head is empty. So we have to check if we're going to add new item. Okay, we need to check if the list is empty. If it is not empty, then we can build our linked list backward, meaning adding the new item to the beginning of the list. Okay, so for the three components here, if the head is empty, so the new node that will be created will be the only node in our list. So the previous initially is null. Okay, the relevant info is the item and the next reference variable is null. Okay, and let the head and tail point to our new node. Okay, else if the head, I mean, if our list is not empty, then we can create a new node Okay, then the previous will point to nothing, so we'll have null. And the relevant info is item, so we'll get the copy of the item here and put it in the component of a node to be created. And the next reference variable and the next component will point to the first node in the list. That is, the address is stored in the head reference variable. And let the head point to our new node. Okay, so that is altering the pointer of the head that will point to our newly created node. And let the head dot next dot previous is equal to head. Okay, now we can print the value of the head. Okay, for example, let's have to print it public void like print head. Okay, printing the item at the beginning, like printing head has a time complexity of O of 1, so we don't need to traverse the list, but we can just simply display the item which is in the head. Okay, like head. Okay, we have to concatenate the value of head using this reference variable head and the item. So head.item will be displayed. Let's try to save. Now to check if we can successfully add the item to the head, we can print the list. Okay? So for printing the list, we have two options. We can print it using forward direction or using the backward direction. Now, let's try to print the linked list in a forward direction. So public void like print forward. Okay. Then we need the traversal variable. And of course, the type is node also. We will use the current traversal variable and let it traverse from the beginning of the list. That is why current is equal to head. That is, point the current to the node whatever the head is pointing to. Okay. And then, so for example, we can have a format of printing first. Okay, that is the statement of printing forward. Then, now we can traverse the list using a loop. Like here, we have the while loop, and it will not stop traversing until current is equal to null. So it will stop traversing while current is not equal to null. Okay, if current is not equal to null, then we have to print in a horizontal form. Okay, so we need to have a space here so that all the items must be printed with a space in between. Okay, so we can print the item using the reference variable current and the variable item. And to update the pointer to the next node, we have current is equal to current dot Next. And of course, if you are printing the linked list backward, so your update statement here is current is equal to current dot previous. Okay. Then we'll try to add a space after printing. Save. Now in the main class, we will try to populate the linked list forward. Okay. So first, we need to create an object of doubly linked list. Say, for example, the object is list is equal to new doubly linked list. For example, doubly linked list. Okay, doubly linked list. Mm-hmm. Okay. Okay, so now we can use this object list to access the public members of doubly linked list. So we can now use the operations of linked list. Okay, using the list dot like add to head. For example, we will try to add 10. And next is let's try to add 20. Then next we'll try to add mm, like 30. So it's expected that we have already three items here. Okay, first we have 10. Okay, since we are going to populate our linked list forward, I mean backward, since it's add to head, the new item to be added is to be placed at the beginning. So 20. Then once you have added 30, you have the list of 30, 20, and 10. Now if you want to display the head, then just list dot print head and display the list in forward direction. Okay, so list dot print forward. Now let's try to save and run. Oops. Oh, okay, so we have an error here. Okay, you have to put this one at the outer to print the item. Okay, with a space in between. Save and let's try to run. Okay, so we have already 30, 20, and 10.